This is being recorded, guys. Okay, this is what we learned last time. If you have coordinate system like this, we call the horizontal line the x-axis, the vertical line the y-axis. This point here, it's called 0, 0, the origin, the fixed point. And this is labeled as 1, 2, 3, 4, 5 to the right of 0. This is the -1, -2, -3, and goes on forever. And this is the +1, +2, +3, +4, and this is the negative right here. And so on and so forth. And to place a point on this system, you need two coordinates. You need the x and y. For example, if I give you 2, 3, to place this point, guys, you go 2 units to the right, and then you go 3 units up, and that would be your point right here. And this is 2, 3. And you can name the point a letter. They usually use capital letters for points. This is called a quadrant 1. This is a quadrant 2. This is a quadrant 3. And this is a quadrant 4. Here, the x is positive and the y is positive. And be honest with you guys, in this chapter, we are interested only in quadrant 1, where the x is positive and the y is positive. In real life, most values are positive, and that's what we are interested in. So you'll be working mainly in this quadrant 1. Okay. If I ask you, for example, to plot the point -2, -1, this is how you do it. You go 2 units to the right, and then 1 unit down right here. And that would be the point right here. -2, -1, and that's the B. This is called the X, and this is called the Y. They call them pairs. They come together, X and Y. You cannot have only one value to draw a point. You need 2 values. So this is about the X and Y coordinates. Any questions, guys, about the X and Y coordinates? Okay, here's my next question to you. If I have this point right here, how many lines I can pass through this point? Can you answer this question?
I'm sorry, what was the question?
How many lines I can pass through this point? Lines, straight lines. What do you say?
2?
2? Well, here's 2. Can you do more?
Infinite.
Do you guys agree with me? It's infinitely many. Look. That's a non-stop. So through one point, you can do infinitely many lines. You cannot do a special one line through one point. Now I'm gonna change my question. I'm gonna put 2 points. Let's call them C and D. How many lines I can pass through the point C and D? Who can answer this question?
1.
One line. That's it. So what I'm trying to tell you guys, if you need to draw a specific line, 1 point will not be enough, because through 1 point, look how many lines I was able to pass. If you want a unique, specific line, you need to know 2 points on the line. If you know 2 points on the line, you will get only exactly the line that you want. So in order to plot a line, you need to know 2 points. For example, if I give you the points, let me just do a new coordinate system and show you on a new grid how this is done. Just gonna take my time with the algebra, guys, because once you understand the algebra, the statistics is just going to be a breeze there. It's not going to be difficult at all. Okay, graph the line passing through 2, 1, and 3, 3. That's the line. Okay, let's see it. 2, 1, guys. You graph 2, 1, 2 units to the right, 1 unit up. That would be the first point right here. This is 2, 1, 3, 3. You go 3 units to the right, 3 units up. That's the point 3, 3. And this is your line, guys. It's unique. That's our line. This is how you sketch the line knowing 2 points. So if I give you 2 points, you should be able to sketch the line. If I give you 1 point, you tell me it's not enough. I need another one. 2 or more is good. Less than 2 is not good. It would not be satisfactory to graph a line. Okay, this line, as you notice, guys, is pointing up. It's going this way. So what would you say, guys, as x increases this way, what happens to the y on this line? Who can make a statement here? So if x increases this way, what will happen to the y?
It gets higher vertically?
It gets higher as well. So when the line, as you move to the right, it points up. As x increases, y increases as well for this line. Let me show you another line where it's a different story. You don't see exactly the same thing that you're seeing here. Watch. Okay, I'm going to give you those 2 points. Sketch the line passing through those 2 points. 1, 1, and 3, -5. Okay. Let's sketch this one. 1, 1 is right here, guys. That's a 1, and that's a 1. 3, -5. 1, 2, 3, 4, 5 right here. And I should have a straight edge. Okay, I'll try to do it. Oh, there you go. I'm going to connect the 2 points. Look, this is how I connect them. And that's your line. That's the line. What do you notice, guys, as x increases now? What's happening to the y? As we move to the right, what's happening to the y? You see, it's not going up vertically, it's going down vertically, so the y is decreasing. So this is an example of a line. As x increases, y decreases. And the previous one was an example of a line. As x increases, y increases as well. So there is a relationship usually between the x and the y value. X is called the x coordinate, the independent variable, and y is called the dependent variable. Those two variables are related somehow. You notice in the previous one, as x goes up, y goes up, but here as x goes up, y is coming down. How do I know it's coming down? Because it's coming toward the negative, guys, as you can see right there. Whereas in the previous one, look, as x moves this way, the y were moving up, so they were increasing. Let me show you a situation and another third situation and see if you can tell me anything about it. Here's another line. Tell me what's happening with the y value as x increases. Okay, let me show it to you right here. That's the line. This is 2 here, and that's so on. What's happening here, guys? As x increases, what happens to y? Any observation? If you had a little bit of
Stay the
beginning algebra, you should know. If you didn't, probably you won't be able to tell me. What did you say? What's happening here? That's a line.
They're staying the same. They're
Yeah, it's in the same.
level.
Look, if x is 1, y is 2. If x is 2, y is 2. If x is 3, y is 2. If x is 4, y is 2. If x is -1, y is 2. When you have a horizontal line, guys, the y does not change. It will remain the same always. So these are the 3 scenarios that I want you to know about lines. This scenario, guys, we're not very interested in. We're interested in those 2 scenarios, this one. That means, guys, as x increases, when you see the line pointing up as you walk to the right, why do I say walk to the right, not to the left? Because the number increase as we go to the right, guys. So as x increases, y increases. Wanted to have good grasp of this so you can absorb what we're going to talk about in a little bit. And let me show you the other example, guys. This. That means as x increases, y decreases. Let me ask you, so x is called the independent variable. You cannot control it, it's independent. But you can control the y because it depends on x. Y is called dependent variable. Can you guys give me some examples in real life about 2 quantities where they have a relationship like this? As the first quantity increases, the second quantity increases as well. And give me another example when the first quantity increases, the second one decreases. A relationship between 2 things from real life situations. Can you come up with something? Okay, I'll give you the x value of 1. The number of hours you work.
Your money increases.
And the money increases, exactly. So as let's say you get paid $10 an hour. The more hours you work, the more money you're gonna earn. X is the independent variable, and you guys agree with me that the amount of money that you earn depends on the number of hours. So it makes sense that the money is the dependent variable. You work 1 hour, you make $10. You work 10 hours, you make $100, and so on and so forth. So the relationship, we say that the relationship between the number of hours you work and the amount of money you earn is a positive. A positive means as x increases, y increases as well. Can you guys think of an example now where the relationship is negative like this?
The more days you have off, the less money you make.
Okay. Okay, that's another one. And I'll give you another one as well. The value, you buy a car. The value of your car will depreciate over time. Do you guys agree with me? Once you get it out of the dealership and you want to take it back the second day, they're going to deduct 25% penalty probably if they agree to return the car. So if you buy a car today, let's say for $20,000, after 1 year, so the years are the independent variable. After 1 year, probably if you want to sell it, you'll sell it for 15. After 2 years, 14. After 3 years, probably 10. After 4 years, probably 9, and so on and so forth. So as time increases, the value of the car decreases. We say that the relationship, guys, is negative. So when x increases and y increases at the same time, we say relationship is a positive relationship. Here we say relationship is negative. Like another example of positive relationship, guys, let's say you want to promote your business. The more ads you put in the papers and social media, etc., probably the more sales you're going to generate. This is a positive relationship. The more money you spend, the less money you're going to have left in your savings account. That's a negative relationship. So when X increases, Y increases as well, you have a positive relationship. As X increases, Y decreases, you have negative relationship. All right. Any questions about this statement? Let me see in the chat if I have anything. Okay, I don't have anything in the chat. Okay. Let's go to the next. Just one sec. Let me get that screen ready for the next part. Just want to take a medicine 1 second. I hope that you guys are keeping safe with what's going on, just with COVID-19 in Michigan. It's getting out of hand, so just try to be very careful. We're not doing well as a state, and even if you are a resident of the city of Dearborn, it's bad here in Dearborn as well. So I'm going to resume sharing right here. And okay, so if as X increases, Y increases, then relationship is positive. That's what as X increases, and if Y decreases, relationship between X and Y is negative. That's how we call it. Okay. I want to show you this is a house. That's a roof. Okay. These are the shingles right there, and that's the roof, 2 sides. This is a line, guys, as you notice. And I can give you an example. Sometimes, just due to weather conditions, a shingle, just comes off from some areas, just on my roof. And I decide whether to go myself to fix it or not based on what factor. I'm not an expert on this. I'm not a professional. I can do, just basic stuff. But what do you guys think? Let's say, just I had the shingle that came off right here and that needs to be replaced. If I'm not, that's not my job to do something, but I can do, just some basic, stuff that do-it-yourself stuff. But what do you think would determine if I should do it myself or not here?
The pitch.
Very good. The pitch of the roof, how steep the roof is. I look at the steepness, guys. If the roof is too steep, I won't take the risk because I'm not a professional and know how to walk, just on the roof. There's a chance that I will hurt, just myself. So it all depends on how steep the roof is. a steepness of the roof. This is a line, guys. If you think of it, just put it in a perspective of a line. It depends on how steep the line is. If it was too steep, guys, I'm talking about something like this. Oh, there is no way that I can go and walk, just on a roof that looks like this. It will be nice if the roof was like this, flat, no steepness at all. Yeah, you walk right here, no problem. I would do it if it was like this, guys. Not too steep. That's not very dangerous, just to do that. But doing it with this roof, I've seen expert professionals, just I have some areas in my roof that are that steep, and I hire professionals. You have to pay, just for that, and they would do it. They know how to walk. They wear special shoes, just to go up, to some area right there. But this is called the steepness of the roof, or the pitch. And steepness in mathematics and algebra, it's called the slope of the line. And what I'm going to teach you right now, we're going to share with you how to find the slope of the line. And the slope is very much the steepness of the line. If you have a line like this, guys, we say that the slope is 0 because there is no steepness at all. If you're driving on a flat road, that is where the steepness is 0. No ups and no downs. But once you start to change into something like this or something like that, you start talking about the steepness. The steepness can be positive, guys, if the line is pointing up this way, and the steepness can be negative if the line is pointing down. And I'm going to show you how to determine the slope of a line. Okay, so let's do this. Actually, you won't be doing this by hand, but you need to understand, just what a slope is. And I'm going to show you it's not difficult, even if you do it by hand, but there wouldn't be questions where you have to do any of this by hand. Let's take 2 points, guys. 1, 1, and 2, 3. So this is 1, 1, and 2, 3. 1, 2, 3 right there. These 2 points, they make a line. So we're going to sketch a line that passes through those 2 points. This is the line. We're going to figure out the slope of the line, how steep this line is. First of all, guys, would you agree with me that the steepness is positive? Because as we walk to the right, the line points up. So it's going to be a positive slope. And let's figure out how to do the slope. The idea of the slope, guys, came from the concept of an airplane. The airplane takes off the runway and then rises. And here is how we find the slope. You take any 2 points on the line, and I'm going to take those 2 points that I picked because I know what they are. And then from the first point, you draw a horizontal line until you are right under the second point. And from this point right there, you draw a line up. This is called the rise, and this is called the run. So the airplane, just runs all that distance, and then it starts, just to rise. And the slope, by definition, guys, is rise divided by run. That is the slope. Okay, can you tell me how much is the rise here, guys? Remember, this point is 1, that's a 2, that's a 3, that's a 1, that's a 2. So how much is this one? How many units are there? Can you guys tell me?
3.
It's from 1 to 3. So what's the distance? How many units?
3.
No, it's less than that. What's the difference between 1 and 3? Isn't it 2 units? Look, this is a 1 unit and this is a 1 unit. So this is 2 units. What's the run? The run is this distance. What's the difference between 1 and 2? 1. And the slope here is 2. It's a positive slope. Now we're going to show you another way, guys. You could have done this without even writing this formula if you know the points. This is called the x of the first point, and this is called the y of the first point. Because I have 2 points, I'm going to label this one as x1, y1, and this is a second point. I'm going to label it as x2, y2. Your slope, guys, can be written with this formula also. It's y2 minus y1 divided by x2 minus x1. So the difference of the y's divided by the difference of the x's. Let's see if I still get that 2. If I don't get that 2, I'm in trouble here. So let's see. y2 is 3 minus y1, which is 1, divided by x2, which is a 2, minus 1. And do the math, guys. It's going to be 2 over 1, which is 2. And this is how we determine the slope of a line. Rise over run. Possible questions you might see in the skills review, guys, something like that. Let me show you. Give you 2 points. Let's just give you, for example, 1, 4. And 5, negative 2. Find the slope. Look what you do, guys. You write the slope equals y2 minus y1 divided by x2 minus x1. And let's decide which one is x1, y1. It's up to you. Let's call this one x1, y1. And this is x2, y2. Okay, let's fill in the formula. y2 is negative 2 minus y1, which is 4. x2, guys, is 5 minus x1, which is 1, equals negative 6 divided by 4, which is negative 3 over 2. And don't be surprised that you see a negative slope because the line is pointing down, as you can see. And you shouldn't be surprised that you saw a positive slope here because the line is pointing up. Now, a slope of 0 means the line is not steep, is horizontal. And let me give you an example where the slope is 0 right there. Let's take those 2 points here, 1, 1, and 3, 1. Okay. You want to find the slope, guys? Let's find the slope. This is x1, y1, and this is x2, y2. And the formula says, by the way, guys, in mathematics, instead of writing the word slope, they use the letter m for slope. So m is the slope. So m will be y2, 1, minus 1, divided by 3 minus 1, which is 0, divided by 2, which is 0. So when you have a horizontal line, guys, you don't need to compute the slope. You should know by heart it is 0 always when you have a horizontal line. So you have 3 lines. Can you guys tell me which one has the largest slope? L1, L2, or L3? L2, I agree, because it's the steepest. Look, guys, watch. This is L2, this is L1, and this is L3 in the middle. So L2 is the steepest. Which one has the smallest slope?
L1.
L1. And then L2 will be, you don't need to know what the slopes are. By looking at them, you should be able to tell, guys. And if I give you this line here, you should be able, guys, to tell that the slope is negative for this line because it's pointing down. You don't need to know what the value is. It is pointing down. As we move to the right, then the slope is negative. Okay, so that's the steepness. You learned about the slope. One more thing we're going to learn about here There's quite a bit of algebra involved, in this chapter, and this is where I spent a lot of time on algebra here. Let me take this line right here. This point, let's say it's 0, 3. And let's say this point is -2, 0. All right. This line, guys, as you notice, it crosses the x-axis and crosses the y-axis. This point here where the line crosses the y-axis, it's called the y-intercept. And as you notice, the y-intercept has always an x equal to 0 right here. And then there is a y, because it is on the y-axis, so it must have an x equal to 0. And this point, guys, probably you can tell what we call it. We call it the x-intercept. And the x-intercept is located on the x-axis. This is when the line crosses the x-axis. And as you notice, the y of this point is always a 0 because it's right on the x-axis. It's not on the y-axis. So it must have a y equal to 0. So these are two special points on the line. We call them the x-intercept and the y-intercept. The x-intercept is when y equal to 0, and the y-intercept is when x equal to 0. Is it possible for the line not to have x-intercepts? Yes, I can give you an example of a line that doesn't have x-intercepts. Watch. This horizontal line. It doesn't cross the x-axis. It only crosses the y-axis right here. Do you guys think it is possible for a line not to have y-intercepts? What do you think? Will you be able to draw a line that doesn't have y-intercepts?
It can just be a vertical line.
Yep, that is correct. We're not interested in vertical line, but yes, vertical line don't have y-intercepts. Actually, guys, we're not interested in vertical nor horizontal. We're interested in those lines which are oblique lines. Either they point up this way or they point down that way. These are the lines that we're interested in them. Okay? One more thing. We're getting close to what we want to achieve. Lines have equations, and let me show you how we represent the equation of a line. You don't need to do any of this by hand. Luckily, your calculator or StatCrunch is going to be able to find those equations of lines. So for example, this line here, it has an equation. Because we need an x value and a y value, the equation of a line is a relationship between x and y. And this relationship, guys, it can be expressed in two ways. I'm going to show you the two ways and tell you which one you're going to try to memorize, because that's what the book, just will be using, the type of equation that I'm going to show you in a second. The equation of a line is a relationship between the x and y values that are located on the line. And here is one way to write an equation of the line. Y equals mx plus b. The m, guys, is the slope of the line. And the b is called the y-intercept of the line. It's when the line crosses the y-axis. So if you know the slope and if you know the y-intercept, you can write the equation of a line. Let me give you an example. If you have this equation, guys, y equals 7x plus 3, and you were asked to find the slope of the line, simply just say the slope is 7. And if you are asked to say what's the y-intercept of the line, you just say it is 3. That is the equation, and this is how you interpret that. Now, if he asks you, write the equation of the line, whose slope is, I want a student to help me with this, whose slope is -2 and y-intercept is 0, 7. Who can help me write the equation of the line here? What would be the equation? All you need to replace m and b by their values. So I'm ready. Y equals what? What would that be, guys? What's the slope here? -2, which is the value of m. So just replace m by -2. And what's the y-intercept? That's 7. Just replace b with 7. And that's the equation of the line. Y equals -2x plus 7. Any questions? Okay, here is another example. Write the equation of the line whose slope, I want one student to answer this, is 5 and passes through the origin. So your line is like this, guys. It goes through the origin. That's our line. What would be the equation? I'll write the formula, mx plus b. Okay, who can tell me what the equation is? Again, the equation is the relationship between x and y. X is the independent variable and y is the dependent variable.
Is it y equals 5x?
Yes. And what's b? Since the y-intercept is the origin, you can see
Plus
the
0?
y-intercept is 0. Yes, so y equals 5x. This is an example of a line that goes through the origin, exactly. So y equals 5x. Yep, that is the equation of that. Now let me tell you what is the interpretation of a slope in real life situations. Probably that's what you need to know, so to have a sense, to have a sense, just of what a slope means. Okay. X is number of items you buy. Y is total price. I'm going to put this relationship here. Y is 10x. This is an equation of a line, guys, and this is the slope. If x was 1, guys, if you buy one item, what would be the total price? Let's make a table here. This is x and this is y. If x was 1, do you guys agree with me that y will be 10? Because 10 times 1 is 10. If x is 2, what would be y?
5.
5 or 20?
20.
When you put x equals 2, 10 times 2 will be what? 20. If x is 3, guys, if you buy 3 units and so you get 10 times 3 is 30. 4, 40, and so on and so forth. So what does the 10 mean here, guys? It means for each item you buy, your price is gonna increase by $10. You buy one item, you pay 10. You buy another one, you're gonna have to pay 10 more. You buy another one, you have to pay 10 more, and so on and so forth. And it is an increase in the cost, as you notice, because the slope is positive. So For each, if you want to interpret, you know, the meaning of 10 here, for each one item you buy, the value of y is going to increase by 10. Now, let me give you an example of a negative slope here. Let's take this. Okay, let's make a table. That's an equation. And help me out, guys. If x is 0, what's y? Put 0 here. Negative 2 times 0 is 0, plus 10 is 10. Now let's increase x to 1 now. What's going to happen to y? Who can tell me what's the value of y now?
The same.
Is it? Put 1 here. What did you get? Negative 2 times 1 is negative 2. Plus 10, order of operation, guys, is 8. Make x equals 2 now. So we're increasing x. Negative 2 times 2 is negative 4. Plus 10 is 6. And you guys can tell what's going to happen to 3 now. Can you guys guess the answer without even doing the work here? 10, 8, 6. What do you think it's going to be here?
4.
4. We're decreasing by 2. If I do a 4 here, can you guys guess what the answer is going to be?
2.
And if I go to 5, what's it going to be?
0.
And so on and so forth. Yes. As the x values increase, the y values decrease. And don't be surprised because the slope is negative. Let me tell you what the interpretation of negative 2 here means. Every time you increase the x value by 1, the y value will decrease by 2. And that's what you notice, guys. Look at the y value decreasing by 2 each time. Here, every time you increase the value of x by 1, the y value increase by 10. And look, from 10 to 20, and then add another 10 and add another 10. So this is the idea of the slope. If you sketch, you know, in order to sketch a line, guys, you only need to sketch 2 points. So in order to sketch this line, all you need to plot the point 110, 220, and you get your line. You connect the 2 points. And same thing for this one. All you need to connect to plot the point 0, 10, and 1, 8, and then you'll get your equation of the line. I can assure you guys, your line here is going to look like this, pointing down because the slope is negative. And your line there, 10x, is going to be like that. It's pointing up because the slope is positive. Your calculator will be able to sketch, you know, just those lines. So we're going to see that in a second. All right. Any questions? So let me just go back. So I plotted some points, guys. They call it a scatter plot. And I'm asking you if you think, you know, just the points are connected, the x and y. And you responded, it seems like they have very much the same slope. Yeah. So do you guys agree with me? It seems like as x increases, the y increases as well. Then they seem to be connected. There seem to be a relationship. And we say linear relationship, as you stated, they might be connected, you know, just with the line. If there is a line that would fit, you know, just all those points, guys, I cannot find it just one line that fits all. That's impossible. But if you ask me to draw a line where you think, you know, just most of the points fit on it, I would draw a line that goes through the middle like this. And yes, they seem to be connected. They are all very close to a line. And this is where we call the relationship is a positive relationship, positive linear relationship. Linear means a line, so you have to include this word here, positive linear relationship. Let me sketch another one. What do you think of this? Do the points seem to be connected, related? Yes or no?
Yes.
This is a definite yes. Not only related, it's actually perfect relationship. They seem to be connected to a line, and all of them go through this line. Look, this is when we say that the linear relationship is perfect. And is it negative or positive, guys?
Negative.
Negative. Perfect negative relationship, linear relationship between X and Y. Okay, let's do a third one. What do you think, guys, here? Do you notice a trend? When I say a relationship, guys, I'm asking you, notice something, a trend that relates the X and Y. This is the X values here, and these are the Y values. And each point, guys, has an X and has a Y in it. It's an order pair. Do you guys feel that they are connected?
Yes. Would that
Yes.
be negative linear relationship?
Linear relationship, but it's not positive. It's what?
Negative.
Negative linear relationship. And if you ask me, guys, find a line that fits all of them, I tell you I can find a line of best fit, but it's not going to go through all of them. And that will be something like this. That would be a line of best fit. And this is negative linear relationship between X and Y. Okay. Here's another scenario. I'm using a lot of papers today just so you can absorb the idea. Do they seem to be connected? Yes or no?
No.
Well, but don't you notice as X increases, what's happening to the Y?
Increases as well.
So then there is a relationship. Maybe as not as strong as the previous ones, but they are connected. As X increases, Y increases. If I ask you guys to draw a line that fits those points, where would your line be? Can someone tell me? If I could share the screen, I would have asked you to annotate with me. There's the pencil. How would I draw the line? Would it be this line? What do you guys think? Yes or no?
Yes.
But if you say yes, you ignore the other four. You didn't take them into consideration. And if I tell you, would it be this line? And if you say yes, you ignore the other four. You didn't take them into consideration. So what would be the compromise, guys? What would be the line of best fit?
The middle.
Yep, you are absolutely correct. This will be the line of best fit, guys. That's like the line that relates them. Although you might argue with...
No, I thought you had to put the line through the actual points.
No, not possible. If we can, we can. But if we can't, what can we do?
Okay.
We could put it through the actual point. We could put it through the actual points if it was like this. I said you need 2 points to sketch a line, but here none of those points are going to be good to sketch the line because my line of best fit is going to be right in the middle. Remember, you're doing a compromise here. You have a few that are on this area and a few that are on the other area. You need to accommodate both of them. The best accommodation is just like to be in the middle. Just like when we did the 50% for probability, when we don't know the probability of success, we say we'll make it 50-50, and it's exactly the same way. I mean, the linear relationship is not going to be very strong here, but there is a linear relationship, and this is how we do the line. Now, let me show you the last example and tell me, guys, if you think that there is a linear relationship or not. Linear means you can tie them to a line. If you cannot tie them to a line, that means the relationship is not linear. Watch this. Do you think this is a linear relationship? Does it look like we can resample a line situation here, guys? It doesn't seem like a resample. You see this curve? Look at this curve here. That's not a linear relationship. That's non-linear. We're not interested in those kinds of situations. We're only interested in the situations where we have a linear relationship. So this is what we're gonna do here. We're gonna learn how to sketch those points using our calculator, and we're gonna be able to learn to tell whether there is a linear relationship between the X and Y values and how strong this linear relationship, and this is all gonna be done through using technology. So that concludes, just the algebra part, and then now I'm going to go to the chapter 9 guided notebook and start from there.